So in this video, we'll look at the new concept about the coordinate vectors, and we assume that you're already familiar with the concepts we have explained in the last couple of videos that includes the linear combinations, the spanning sets, and the meaning of bases already. So in that case, let's assume that you're having a vector space V, and let's say one basis is given for such a vector space, and we try to present any vector in the base V with respect to the basis as a coordinate vector here. Basically, it's just a notation for the meaning of coordinate vector with respect to the basis S. And the real fact is that you have to find the coefficients C1 up to Cn such that V can be presented as a linear combination of the given vectors here. And of course, this fact is always satisfied for any vector in V, because we understand by the definition of basis, any vector now is inside the span of the set S, which means any vector is a linear combination of the given vectors in the set S. And let's look at some examples now. So let's say now in the vector space R2, which is two-dimensional, I'm taking the standard basis. You see, standard basis means these are the vectors on the x and the y axis respectively. And then now let's say I give you a vector like 5, 6 inside this space, right? And I think it's quite easy, right? In the standard case, the answer is actually obvious. I can just write it simply as a linear combination of the two given vectors here. And it means by our new terminology now, we can present this given vector W as a coordinate vector with respect to our current basis. Let's say the set is S. And in that case, it means I can present it like this. And I think there's actually nothing special, right? Because this one is simply the usual way we present any vector on the xy plane by the x coordinate and the y coordinate, right? However, if the basis is a non-standard one, if I change the vectors in the basis, it's quite clear that the coordinate vector would be changed, right? And let's look at more examples now. Please look at the given two vectors here. I think it's quite sure it is actually a basis for the R2 because we can just take the determinant of these two matrices. You can just take the determinant of this matrix which have the columns as V1 and V2, and you can see it is clearly non-zero, and it means it is a basis. It's a simple check, and get the same vector again. Can you tell me the coordinate vector with respect to this basis S1? So I want something like this. You have to tell me the coordinate vector with respect to the basis S1, right? And let's do it together. And basically, you need to find certain coefficients C1, C2 attached to the two vectors here as a linear combination. And I leave it as an exercise for you. But the answer is that you can use 1 as C1 times 1 comma 2 for the first vector plus the second vector is going to be 4 times the V2 like this. And you can check that such a vector equation is true. It is the same as 5, 6 on the left-hand side. It basically means what? Because the first coefficient is 1, the second coefficient is 4, I can put the coordinate vector as 1, 4 with respect to a new basis as 1, right? And I hope you kind of understand the way to find the coordinate vector now. You see, these two are not the same. If you look at these two, they are not the same, right? The coordinates are changed because you are using a different basis. And that's the end of this video.